the silence before memory is a peculiar one. It is not empty, not void, not absence, but a kind of deep waiting. Imagine standing at the edge of time, before the first thought was spoken, before the first fire was stolen from the night. There is no civilization here yet, no sound of tools, no echo of invention, only the quiet pulse of the planet beneath layers of cloud and stone. In that silence, the future hums softly, like an idea not yet born. When we think of progress, we imagine a forward march, from simplicity to complexity, from cave to city, from spark to silicon. Yet what if the story is not a straight line, but a loop? What if every age of discovery is not the first, but a rediscovery, a remembering? Beneath the surface of our achievements might lie an older rhythm, one that time has played before and will play again, endlessly, until we learn to listen to its echo. The earth, after all, does not forget. Every layer of soil is a page in a slow, patient book written in dust and pressure. Mountains rise and are ground back to sand, oceans open and close like lungs, and civilizations, if there have been others, dissolve back into the same mineral ink that once shaped them. Time covers all traces, but it does not destroy, it merely folds them under, preserving the memory in geological silence. When we gaze at the stars, we think of beginnings. Yet the light we see is ancient, sometimes older than life itself. The photons that touch our eyes have traveled for eons, carrying news from a universe that existed long before our world cooled. In that sense, we live surrounded by the past, breathing its radiation, walking on its fossils, thinking with the atoms forged in the hearts of long-dead suns. Perhaps the same is true of knowledge. Perhaps ideas themselves recycle, returning again and again like the tides. Somewhere between curiosity and arrogance, humanity began to believe it was the first to invent, the first to dream, the first to name the stars. But the ground beneath our feet tells a quieter story. It hints at cycles, not beginnings. It whispers that everything which seems new may only be reawakened, technology, language, even consciousness itself. We might not be pioneers, but inheritors. What would it mean if our machines were not innovations, but repetitions? If the wheel, the gear, the circuit, all these symbols of intellect, had turned before under other hands, in other epochs? Would time allow us to know? Or would it bury every trace beneath epochs of forgetting, until only intuition remained, the faint sense that we are not alone in the story of creation? The silence before memory becomes heavier when we realize that silence might not mean absence. It might mean protection. Perhaps time guards its secrets not to erase them, but to keep them from burning us again. Maybe the lost technologies of forgotten civilizations were never destroyed by nature but by understanding too soon what they were never ready to wield. Yet in that same silence lies a beauty, the idea that even if civilizations vanish, the impulse to create, to discover, to reach for the unknown, is eternal. It is not the property of one species or one age. It belongs to the universe itself, repeating its own genius through the patterns of evolution. Each mind that wakes, each hand that shapes, continues the work of all who came before, known or unknown. So the story begins here, not with invention, but with remembrance. In the quiet before progress, in the breath before the first spark, we listen for the rhythm beneath history's noise. We feel it pulsing through the rock, through the ocean, through the ancient air that has circled the planet countless times. The silence before memory is not a void, it is a promise. It promises that what has been lost may one day return, that what time tried to erase still hums faintly in the dark, and that perhaps, as we stand surrounded by our machines, our circuits, our towers of glass and light, we are not witnessing the birth of intelligence, only its return.
Beneath our feet lies a history written not in ink, but in pressure, temperature, and time. The Earth's crust is a library so vast that even its oldest chapters have been folded, crushed, and rewritten by the slow hand of geology. Yet between its pages, in seams of rock, in buried sediments, in forgotten minerals, lie questions that defy easy answers. Questions about what once lived and what once thought. Every layer of the Earth is a boundary between worlds. The soft limestone of an ancient seafloor rests beneath volcanic ash from some later apocalypse. The fossils of trilobites sleep under the imprint of forests that no longer exist. To a geologist, these layers are time itself, visible and measurable. But to the dreamer, they are memories, stacked, compacted, and hidden away, as though the planet has been trying to remember something it once knew and then lost. Scientists dig into these layers, searching for the history of life, but sometimes they find things that do not quite fit. In ancient coal seams, metallic spheres have been unearthed, tiny, grooved, and perfectly balanced, as though machined. In other deposits, geometric structures appear, embedded in stone tens of millions of years old. Some dismiss them as natural curiosities, products of mineral growth or geological coincidence. Others wonder if they might be fragments of something forgotten, remnants of an intelligence that vanished long before we walked the plains. Of course, extraordinary claims demand extraordinary evidence. Science moves carefully, resisting the seduction of mystery. Yet, it also acknowledges how incomplete our record truly is. Less than a fraction of Earth's history is visible to us. Most of it has been subducted into the mantle, recycled by tectonic movement, melted and remade into new stone. If a civilization existed in deep time, millions of years before our species, its artifacts would not survive as ruins. They would survive, if at all, only as distortions in the chemistry of rocks. This leads to a haunting thought. What if the traces are already here, but we no longer recognize them? A civilization's footprint might be subtle, a layer rich in synthetic molecules, isotopes that should not occur naturally, or metallic alloys too uniform to be of geological origin. The signs might be buried within the geochemical noise of natural processes, indistinguishable from volcanic residue or meteor dust. To find them, we would need to look at the Earth not as a planet of nature, but as an archive of its own mistakes and miracles. Some researchers call this the search for technosignatures, physical evidence of technology in deep time. We have begun scanning other planets for such signs. The faint spectral traces of industry in alien atmospheres, the reflective scars of artificial satellites circling distant suns. Yet rarely do we turn the same instruments inward toward our own world to ask if something similar might lie beneath us. The rocks we walk upon may hold the echoes of machines that have long since turned to dust. In certain places, the evidence feels almost too poetic. Metallic nodules discovered within Precambrian formations, perfectly spherical, some with delicate ridges running around their equators. Footprints that appear to cross stratigraphic boundaries, carved into stone millions of years before humans evolved. Each discovery is debated, dismissed, re-examined. Nature is creative, capable of sculpting forms that mimic design. But even if all are coincidences, they remind us how little of Earth's deep story we truly understand. Consider this. The Earth is over 4.5 billion years old. Modern humans have existed for only about 200,000 years. Our industrial age, the period in which we have reshaped the surface of the planet, spans barely 3 centuries. That is less than a heartbeat in geological time. If another civilization had risen and fallen even 50 million years ago, the record of its existence would have been erased 100 times over. Mountains would have crumbled. Oceans would have reclaimed their plains. Glaciers would have ground every monument into dust. The silence beneath the strata is not the silence of emptiness. It is the silence of immense compression. Every atom below carries the weight of lost eras, the memories of forests turned to coal, of animals whose names were never spoken. If there were technologies among them, they would not remain as relics, but as whispers in the mineral code of the planet. Imagine standing in a canyon where the rock walls are painted in layers, reds, browns, and pale grays marking millions of years of sediment. To most eyes, it is beauty. To a scientist, it is data. But to a philosopher, it is a reminder that time buries everything, including itself. Somewhere deep in those bands might be the ash of a civilization's fire, the faint residue of smelted ore, or the molecular ghosts of a vanished experiment. And if the planet holds such secrets, what does that say about our own future? One day, our skyscrapers, our satellites, our roads will also be folded into the crust. Plastic will become sediment. Steel will become ore. The earth will digest us, as it has digested all things before. Millions of years from now, perhaps another species will walk upon our remains, puzzled by strange alignments in the rocks, unusual isotopes, or a layer rich with synthetic carbon compounds, the thin, glittering scar of an age that burned too brightly and too fast. We may be the next anomaly beneath the strata, the next mystery future minds will debate, whether we were natural or artificial, whether our rise was inevitable or accidental. The ground beneath us does not distinguish between myth and truth. It swallows them both, pressing them together, until even the most advanced technology becomes just another mineral inclusion, indistinguishable from the rest. In the end, the rocks remember everything, but they tell us almost nothing. They guard their stories in pressure and silence. The deeper we dig, the quieter they become. Yet still, they hold that lingering question. Are we truly the first? Or merely the latest in a line of civilizations the earth has patiently buried, waiting for anyone, to listen closely enough to hear their echo through stone? Fire. It is the symbol of our beginning, the shimmering veil that divides darkness from knowledge. To hold fire was to command transformation. It meant warmth, protection, invention, and eventually, the birth of all technology. Yet, across the myths of the world, fire is never simply found. It is stolen. It is taken from gods, from sky, from beasts, as though humanity was not inventing it for the first time, but reclaiming what had once been lost. In the Greek myth, Prometheus defies Olympus to bring flame to humankind, an act of rebellion punished with eternal torment. In India, Agni is the divine messenger who carries offerings between mortals and gods, a keeper of sacred energy older than the world itself. In Polynesia, the trickster Maui wrestles fire from the underworld, bringing it back to the surface after it had been forgotten. In each story, fire is not created, it is returned. These tales are too consistent, too universal, to be coincidence. They suggest a deeper memory, that something vital had been extinguished before, and that humankind's first discovery may have been an act of rediscovery. What if the myth of the first flame is not just metaphor, but inheritance? Perhaps the memory of ancient technology, lost in deep time, survives in the language of stories, encoded as gods, heroes, and divine punishments. When knowledge fades and civilizations crumble, the remnants of their science often persist as myth. Astronomy becomes astrology. Engineering becomes magic. And what was once machinery becomes miracle. The story of stolen fire might be the symbolic echo of a civilization that once knew how to command energy, a knowledge so powerful and dangerous that its memory had to be shrouded in cautionary legend. The first spark on Earth was not born in a human hand. It existed long before us, in lightning striking volcanic plains, in meteors burning through the atmosphere, in the ceaseless friction of tectonic plates beneath the crust. Fire has always belonged to the earth itself, and perhaps to others before us who learned to speak its language. To tame fire is to unlock chemistry, metallurgy, and transformation itself. If any intelligent beings walked this world before us, they too would have known its power. And when they vanished, the memory of that mastery may have drifted across epochs, surviving only as a whisper in the collective unconscious of later species. There is a theory in anthropology known as cultural recurrence, the idea that certain inventions emerge independently again and again because the conditions of the world make them inevitable. The wheel, the bow, the kiln, each rediscovered by different peoples separated by oceans and centuries. Yet what if these recurrences are not coincidences but faint recollections? What if the designs already existed, buried not in soil but in mind, inherited impressions from a time when the world had already been shaped by another intelligence? Fire is a bridge between matter and thought. To burn something is to transform it, to change its state, to release what was hidden. It is creation through destruction, an alchemy that mirrors consciousness itself. When we light a flame, we mimic the stars. When we forge metal, we mimic the Earth's molten core. The act of creating technology is the act of awakening nature's own forces within a smaller, controlled form. In that way, perhaps every technological leap, every spark of invention, is a reenactment of something primordial, a pattern embedded in the universe long before any species learned to name it. Imagine, then, that our myths are not pure invention, but encrypted archives. The legends of the gods descending from the heavens could be ancestral echoes of a technologically advanced race, human or otherwise, whose machines, bright and godlike, once lit the skies. The stories of great floods, global fires, and divine retribution could be the distorted memories of planetary resets, times when civilization burned itself out. When we say fire was stolen from the gods, perhaps it means knowledge was stolen from those who came before. But fire, in myth and in life, always comes with a warning. It gives and it consumes. It empowers and it punishes. The Greeks knew this. Prometheus's suffering was not for the theft itself, but for sharing the flame too freely. In that sense, the story becomes prophetic. Every age of discovery walks this same edge, the balance between illumination and annihilation. To harness energy, whether flame, fission, or fusion, is to touch the core of creation itself, and few civilizations seem to handle it gently. Perhaps this is why fire keeps being lost. Not because time erases it, but because civilizations do. When the balance tilts too far, when invention outpaces wisdom, fire turns inward, consuming its keepers. The earth resets. The knowledge fades. The survivors remember the glow, the heat, the terror, and they tell stories of how it must never be stolen again. Until one day, curiosity burns brighter than fear, and the cycle begins anew. There is something profoundly human in that story, yet something also universal. Fire, like consciousness, is restless. It seeks hands to hold it. It seeks minds to understand it. Across the deep time of this planet, that impulse, to transform, to ignite, to reach beyond the given, may have belonged to more than just us. Each species that learns the secret of the flame, literal or metaphorical, becomes a new chapter in a long looping experiment. How many times can the universe teach intelligence before it learns restraint? So when we stare into a campfire or watch the blaze of a rocket leaving Earth, we are not merely seeing technology. We are witnessing a ritual as old as the cosmos. The flame is both memory and prophecy, a bridge across forgotten eras. It is the same light that burned in myth, in storm, in stone, and in the heart of every mind that ever dreamed of power. And in its dance, there flickers a quiet truth, that perhaps the first flame was not a beginning, but a return, a moment when the universe remembered itself again through us. When we imagine the fossils of life, we picture bones, shells, and petrified trees, the imprints of living bodies turned to stone. But the fossils of intelligence are not so easily seen. They are not shapes that can be held, nor skeletons that can be reconstructed. The fossils of intelligence are subtler, written in chemistry in isotopes, in the delicate balance of elements that make up the Earth's crust. They are the faint, lasting fingerprints of thought, the residues left when a species learns to change its environment. Modern scientists have a word for these traces: technofossils. They are the physical record of a technological civilization, objects and alterations that could endure long after their makers are gone. A plastic fragment trapped in marine sediment, a layer of carbon from industrial burning, a faint but measurable rise in atmospheric isotopes that should not occur naturally. These are the signatures of our age, the quiet, chemical evidence of human existence. But what if such signatures existed long before us? What if, in some ancient stratum, the Earth has already recorded a civilization's rise and its disappearance? This question is not fantasy. In 2018, two scientists from NASA and the University of Rochester proposed what they called the Silurian hypothesis. It asked, quite simply, if an industrial civilization had arisen on Earth millions of years before humans, could we detect it today? Their conclusion was unsettling. After a few million years, nearly all direct evidence, buildings, machines, artifacts, would be gone. The slow churn of geology would recycle the crust, subduct continents, and erase almost everything. Only indirect traces might remain, small chemical anomalies, like sudden spikes in carbon, nitrogen, or synthetic molecules. The fossil record, so often treated as an archive of life, might also be an archive of mind. Yet we rarely look at it that way. We see a thin layer of black shale and call it the residue of ancient algae blooms. We find an isotope imbalance and call it the result of volcanic eruption. But if another civilization had burned fuel, mined minerals, or altered its biosphere, its traces would be nearly identical. The Earth does not distinguish between the byproducts of biology and the byproducts of technology. Both are chemistry, both are transformation, both leave behind the same quiet scars. Consider the Carboniferous period over 300 million years ago, an age of immense forests and vast swamps. It left behind enormous coal deposits that fueled our own industrial revolution. But buried within those layers are curious anomalies. Unusually pure bands of carbon, irregular concentrations of metals, subtle isotopic deviations that scientists still debate. All are explainable through natural processes, yet the pattern feels eerily familiar, as though Earth had already endured a cycle of combustion and recovery. We burn ancient carbon now. Perhaps long ago, someone else burned theirs. To think this way is to stretch the imagination across eons. We are accustomed to history measured in centuries or millennia, but the Earth measures memory in millions of years. Entire continents drift, collide, and dissolve in less time than it would take to fossilize a civilization. A future geologist might find traces of our age only as a strange, narrow line of mixed plastics and metals, the Anthropocene layer, as scientists already call it, thin enough to be missed, brief enough to be forgotten. So what, then, of the deeper layers, the ones far below the reach of our archaeology? Could they hold their own Anthropocenes, long compressed into obscurity? We have already discovered minerals that seem artificial by nature, complex metallic compounds that should not form under the pressures of natural geology. We have found patterns in magnetic rocks suggesting sudden planet-wide heating events, not entirely explained by known causes. We have unearthed microstructures that resemble industrial slag, dated to millions of years before humans existed. Each discovery meets skepticism, as it should. Yet together, they form a chorus of quiet maybes. And even if all of it is coincidence, that coincidence is telling. It reveals that the Earth itself behaves like a civilization. It creates, it destroys, it recycles. Volcanoes smelt metal. Oceans refine salt. Lightning forges glass. Nature, in its own way, manufactures. Perhaps that is why our own technology feels so inevitable, because we are the continuation of the planet's chemistry, an extension of its long experiment with transformation. Intelligence is simply the Earth learning to look at itself. To imagine technofossils of the past is not to dream of alien visitors or myths of lost continents. It is to acknowledge that intelligence might not be rare, but cyclical. It could arise wherever conditions permit, then vanish, leaving behind the faintest residue, a kind of geological afterimage. Over millions of years, those traces would blur, sink, and merge with the natural record, until no difference remained between artifact and mineral, between culture and crust. Perhaps we have already seen the evidence, but our language cannot yet name it. To us, it looks like stone, like sediment, like the bones of an ordinary world. But to time, that quiet witness, it may be the fossil of a dream repeated again and again, a planet waking to consciousness, building, burning, and beginning once more. If so, then we too are fossils in progress. Every machine we make, every structure we raise, every atom we split, all will one day be compressed into the same deep archive. Millions of years from now, long after the memory of our names has dissolved, someone or something might dig into a layer of rock and find the telltale shimmer of polymer, the trace of alloy, the ghost of electricity etched into crystal. And they might wonder, as we do now, if they are the first. The fossils of intelligence are not meant to be found easily. Time guards them with silence, with gravity, with endless renewal. Yet they remain faint, quiet, patient, woven into the bedrock of the world. The earth keeps its memories well. It has buried civilizations before, and it will do so again, each one leaving behind a whisper in the stone, a reminder that thought itself is as ancient and enduring as the planet that holds it. Ancient stone carries memory, not the memory of minds that we can read in words or numbers, but a memory embedded in form, in alignment, in the almost imperceptible perfection of placement. When we look upon a megalith, a monolith, or a perfectly hewn temple wall, we are seeing more than stone. We are seeing a message preserved across millennia. Each cut, each joint, each deliberate placement is a quiet testament to skill, intention, and perhaps knowledge that has been lost to the ages. We marvel at the precision of structures like the pyramids of Giza, where massive blocks fit together so perfectly that even a thin blade cannot pass between them. How were they lifted, aligned, and placed without machinery as we understand it? The questions grow more intriguing when we consider other sites. The walls of Sacsayhuaman in Peru, the Cyclopean terraces of Baalbek, the mysterious arrangements of Göbekli Tepe. The stone seems to speak in a language we no longer understand, yet the echoes of that language ripple through time, hinting at a knowledge we might never fully recover. Some scholars attribute these feats to human ingenuity alone, the perseverance and creativity of ancient civilizations. Yet a deeper contemplation suggests another possibility, that these structures might be vestiges of techniques already known and then forgotten. Perhaps ancient builders were not inventing these methods for the first time, but rediscovering them, recovering the whispers of a lost engineering tradition encoded in myth, memory, or intuition. What if the precision of these constructions is evidence of a knowledge that predates recorded history, a wisdom of stone that cycles through civilizations like a hidden rhythm? It is not only the size or the alignment that fascinates, but the subtlety of design. Many of these structures are oriented with celestial precision, aligned to solstices, equinoxes, or particular stars. Such meticulous attention suggests more than practicality. It implies a philosophy, a worldview, a desire to integrate human work with cosmic patterns. Could this knowledge of the heavens have been rediscovered multiple times, each civilization finding its own way to map the sky into stone? And if so, what did those who came before us know about the movement of planets, the passage of time, or the cycles of energy that we barely begin to comprehend today? Stone itself is a teacher. Unlike wood or metal, it endures, absorbing time without decaying. It can preserve inscriptions, carvings, and alignments for tens of thousands of years. The Earth's crust has acted as a custodian, storing these messages through erosion, tectonics, and the passage of centuries. But just as nature preserves, it also transforms. Over millennia, knowledge embedded in stone can be obscured, reinterpreted, or lost entirely. What seems miraculous to us may have once been ordinary, a common technique repeated, refined, then forgotten as civilizations rose and fell. There is a quiet poetry in imagining that our ancestors were not alone in their achievements, that each carefully placed stone might be a continuation of an earlier line of builders, a long, looping conversation across time. Each quarry, each chisel mark, each alignment could be a sentence in a story whose first chapters have been erased, whose middle chapters we glimpse only through fragments, and whose last chapters are yet to be written. In this view, the earth is not merely a stage for human activity. It is a ledger in stone, recording the rise, fall, and rediscovery of knowledge across epochs. The act of building with stone is also an act of memory itself. As each block is shaped and placed, as each temple or monument rises, the builders encode understanding into permanence. Mathematics, geometry, physics, and astronomy are not only tools, but expressions of a civilization's capacity to observe, to learn, and to persist. What survives may be only a fraction of the original knowledge, yet it is enough to whisper, across centuries, that humans, or perhaps beings before us, once knew more than we now remember. Perhaps these monuments were not meant merely as tombs or temples, but as messages to the future. They endure not because of their function, but because of the story they carry, a story of persistence, intelligence, and the continuity of thought. Every precise joint and every deliberate orientation is a punctuation mark in a language that has been partially erased. We can read it faintly, and it provokes awe, curiosity, and a quiet humility before the labor and understanding of those who came before. Even in decay, stone teaches. Weathered carvings, cracked columns, and eroded terraces remind us that knowledge is impermanent, even in the most durable materials. Yet the underlying message persists: alignment, proportion, precision. These endure. The builders encoded logic into the very molecules of their constructions, a logic that can survive erosion, fire, and the collapse of empires. If this is a fossil of intelligence, it is a remarkably resilient one, a record that can be read, interpreted, and reflected upon by minds far removed from the original creators. So when we gaze upon the monuments of the ancient world, we are witnessing more than architecture. We are witnessing memory itself. Stone becomes an archive, a library, and a mirror. It reminds us that knowledge can be buried, lost, and recovered, but the traces, subtle, enduring, and profound, always persist. Perhaps one day, these messages will be fully understood. Perhaps they are already speaking to us, waiting for the patient ear that listens long enough to hear not just the stone, but the civilizations it once served and the wisdom it has preserved through time. Beneath the ocean's surface lies a memory that is both ancient and elusive, a record written not in stone, but in water. The seas are more than vast expanses of liquid. They are living archives, keeping the stories of continents swallowed, cities submerged, and civilizations lost to the rise and fall of tides and tectonic shifts. Every wave, every current, every shifting sand dune on the ocean floor carries whispers of what once was, hints of human ambition, or perhaps even the ambition of beings that walked the earth before us. To explore these waters is to explore the archives of time itself. Throughout history, rising oceans have claimed coastlines, drowning settlements and erasing them from sight. The story of Doggerland, once a thriving landscape connecting Britain to continental Europe, reminds us that the ocean does not forget, it merely waits. As sea levels rose at the end of the last ice age, the forests, rivers, and human habitations of this land sank slowly beneath waves. Today, sonar scans and archaeological dredges reveal faint outlines of habitation, sunken rivers, mounds, and depressions, reminders that the planet's waters can act as custodians of history, preserving in their depths what the land itself may have long since erased. Other submerged mysteries provoke a sense of awe and speculation. Off the coast of Japan lies the Yonaguni Monument, a massive, terraced rock formation beneath the Pacific, resembling terraces and steps meticulously carved. Some scientists argue that these are naturally formed, products of erosion and tectonic pressure. Yet others propose that the precision of the angles, the symmetry, and the scale suggest human hands, or perhaps the hands of intelligent beings long lost to time. The ocean conceals as it protects, holding these artifacts in a silent archive, inaccessible to casual eyes, waiting for discovery, or perhaps simply content to remain unseen. Water has an uncanny ability to preserve. Unlike the atmosphere, which oxidizes and decays, or soil, which transforms and erases, deep oceans maintain stable temperatures and pressures, acting as a slow-motion vault. Organic materials, wooden structures, even metals can survive in the right conditions for millennia. Coral, silt, and volcanic ash can entomb objects, shielding them from decay, while the shifting currents slowly sculpt the ocean floor, sometimes revealing fragments of the past, sometimes burying them further in sand and sediment. The ocean is both archivist and editor, deciding what is seen, what remains hidden, and what is lost forever. In some cases, the ocean itself seems to preserve anomalies that defy explanation. Strange, unnatural shapes, geometric formations, or metallic deposits appear scattered across the seabed, often only detectable through sonar scans or submersible explorations. While science leans toward geological explanations, the possibility that these are remnants of past intelligence, structures, tools, or monuments, cannot be entirely dismissed. If time and tide have already swallowed civilizations before ours, what might their ruins look like? Could they exist now, draped in layers of silt and coral, their stories muted by the gentle push and pull of currents over millions of years? The ocean is patient, more patient than humanity itself. Where we measure time in years, decades, or centuries, the sea moves in eons. A sunken city may lie undisturbed for tens of thousands of years before a storm shifts sediment enough to reveal a hint of its existence. The waters absorb our noise, the tide erases footprints, and yet, paradoxically, the ocean is an excellent preserver. In this duality, destructive and preservative, the ocean mirrors the way time works upon civilization. It is the custodian of memory, keeping safe what the land cannot, hiding it in plain sight beneath a liquid canopy. Some submerged landscapes are so ancient that they predate human civilization entirely. Continental shelves, now underwater, once bore forests, rivers, and plains where creatures we can scarcely imagine roamed. Humans may have walked these lands at times, leaving traces that have since been drowned by rising seas. Or perhaps other intelligences, not human, but sentient, might have experimented, built, and vanished beneath waters that now silently cover the evidence. To consider such possibilities is not to embrace fantasy, but to confront the profound incompleteness of the geological and archaeological record. The ocean reminds us that absence does not imply non-existence. Moreover, the ocean moves constantly, reshaping its own archives. Tides, currents, and subaqueous landslides can bury structures one day and expose them the next. In this rhythm, there is a lesson for understanding time itself. History is not fixed nor linear. It is fluid, cyclical, and layered. Civilizations, whether human or otherwise, leave imprints not just on land, but on the waters that eventually reclaim and reinterpret them. Our understanding of the past depends on what survives these currents, both natural and cultural. Even now, modern technology allows us glimpses into these hidden archives. Sonar mapping, deep-sea submersibles, and satellite imagery reveal vast, previously unrecognized formations. Some appear as ridges and terraces, others as depressions and channels that could once have been roads, rivers, or canals. Every discovery teeters between natural process and human or pre-human design, blurring the line between possibility and probability. The ocean's memory, in this sense, is a puzzle written in liquid stone, waiting for patient listeners who can read it across layers of sediment and time. The ocean, in all its depth, is also a metaphor. It reflects the way civilizations can rise, flourish, and vanish, leaving only hints of their existence beneath a surface that appears tranquil. Like memory itself, it is at once revealing and concealing, shaping what will be remembered, what will be forgotten, and what will linger, faint and mysterious, in the subconscious of the planet. To explore it is to confront the silent persistence of history, the slow accumulation of time, and the subtle yet indelible traces of intelligence that may have come before us. So, as we consider what lies beneath, we are reminded that the ocean is not merely a barrier or an abyss. It is an archivist, a preserver, and a witness. Its waters may conceal ruins, artifacts, and technologies that predate our knowledge. Its tides may protect secrets that the land could never keep. And perhaps in the quiet undulations of the deep, the whispers of civilizations long gone, human or otherwise, continue to speak, waiting for the patient mind to listen, and in doing so, to awaken a sense of wonder that bridges time, memory, and the vast, enduring depths of the sea. Across the sweep of human imagination, stories of machines have always shimmered at the edge of reality and myth. Ancient texts describe automata that move on their own, intricate contraptions that anticipate the will of their masters, and vehicles that soar across the skies with impossible speed. These are not tales of mere toys or curiosities. They are expressions of humanity's longing to harness forces beyond its natural capacity, to create tools that mirror thought itself. From the bronze automata of Greece to the legendary Vimanas of India, these stories are scattered across cultures, across centuries, hinting at a knowledge that might once have been, and perhaps will be again. The Greeks constructed mechanical devices capable of astonishing complexity. Hero of Alexandria, a mathematician and engineer of the 1st century CE, described automata that could serve wine, open temple doors, and even simulate theatrical performances with remarkable precision. These machines were powered by steam, air, and cleverly designed mechanisms, demonstrating a level of ingenuity that still inspires modern engineers. Yet Hero's creations, as elaborate as they were, seem almost ordinary compared to the machines whispered of in myths. Could these stories have been echoes of inventions that predated Hero himself, technologies that had already existed and were lost over centuries? In India, ancient epics, such as the Ramayana and Mahabharata, describe Vimanas, flying chariots with the ability to traverse air and even space. The descriptions are detailed. Vimanas are said to be crafted from metals unknown to ordinary humans, powered by energies that could not be tamed by ordinary mortals, and capable of feats that stretch the imagination. Scholars debate whether these are symbolic, allegorical, or literal accounts. Yet the recurrence of such descriptions across distant times and places hints at a deeper memory embedded in human consciousness. Might these stories preserve, in symbolic form, the memory of technological achievements long lost to history? The line between myth and reality blurs further when we consider artifacts like the Antikythera mechanism, discovered in a shipwreck off the coast of Greece. Dated to the 1st century BCE, this mechanical device is essentially an analog computer, capable of predicting astronomical positions and eclipses decades into the future. For decades, scholars debated whether such precision could have been achieved in the ancient world, until detailed analysis confirmed its sophistication. The mechanism forces us to confront the possibility that our ancestors understood far more about machinery and the cosmos than we often assume. That knowledge can be simultaneously advanced and hidden, present and invisible, waiting for rediscovery. Other myths speak of automata that move without human intervention, sometimes even exhibiting behaviors that resemble learning or adaptation. In the East, there are tales of mechanical birds that sing, humanoid figures that dance, and objects that respond to commands with apparent intelligence. While some of these accounts may be exaggerated, they reflect a profound human fascination with self-moving machines, a fascination that suggests a conceptual understanding of automation and engineering that is ancient, perhaps predating the written record. Could these myths be the poetic preservation of knowledge that was once practical, not symbolic? The prevalence of these stories across cultures is striking. Civilizations separated by oceans and centuries, with no apparent contact, describe similar marvels of technology. Could this convergence indicate that technology itself is inevitable, that any sufficiently intelligent society will discover mechanisms that extend their will beyond the body? Or is it possible that some knowledge persists through the cultural memory of a lost civilization, transmitted in myth, surviving as story where physical artifacts could not? The mind naturally wonders whether these tales are symbolic placeholders for real machines that have been erased by the passage of time. Stories of fantastical machines also carry warnings. Many myths depict automata that turn against their masters, flying chariots that wreak destruction, or mechanical marvels that are too powerful to control. This duality, marvel and menace, suggests a philosophical awareness of technology's danger. Machines are tools, but they are also extensions of intention, and intention can be flawed. Ancient storytellers may have encoded the ethical dimensions of invention into myth, a subtle reminder that technological prowess without wisdom can be catastrophic. In considering the machines of myth, we also confront the idea of memory itself. Could these stories act as cryptic archives, preserving principles of engineering, mechanics, or energy manipulation in symbolic form? Perhaps the ancients encoded practical knowledge within allegory, embedding instructions for those capable of interpreting them correctly. In this sense, myths are not merely entertainment or moral tales. They are repositories, waiting for minds curious enough to decipher the wisdom hidden within narrative patterns, allegories, and repeated motifs. Even today, the study of these ancient machines inspires contemporary science and engineering. Robotics, automation, and artificial intelligence all trace their conceptual roots to these early imaginings. The spark of ingenuity that produced a bronze automaton or a flying chariot echoes into modern laboratories, reminding us that technology is not only the product of the present, but the culmination of ideas that have traveled through time, sometimes obscured, sometimes lost, sometimes reborn. Ultimately, the machines of myth challenge our understanding of history. They force us to question whether human ingenuity is linear and original or cyclical and iterative. Perhaps we are rediscovering what has been known before, following paths traced by others whose names have been erased. The myths tell us that technology can exist beyond the visible, beyond the record, surviving only as story, only as suggestion, only as memory. They are, in a sense, a testament to the possibility that what is lost is never truly gone, that the imagination, and perhaps the intellect, is a kind of machinery that persists, awaiting the hand capable of activating it once more. The flow of time is relentless, yet it is neither linear nor simple. Civilizations rise, flourish, and vanish, leaving behind traces that are at once fragile and enduring. Yet not all traces are visible in the conventional sense. Some are hidden in the layers beneath our feet, some are whispered in myth, and some are encoded in the very chemistry of the planet. To seek these traces is to confront the idea that history may not be entirely human, that the earth itself might carry the memories of intelligences that preceded us. Consider the vanished cities that lie buried under sand, silt, or ice. The ruins of ancient civilizations can be swallowed by desert, drowned by rising seas, or crushed beneath tectonic pressure. Yet even as they vanish, subtle clues persist. Aligned stones hinting at a once thriving city, isotopic anomalies in soil suggesting large-scale metallurgy, and sediment layers that bear the fingerprints of human activity. In these faint records, archaeologists detect the pulse of lives lived long ago. Now imagine these pulses extending far beyond the horizon of known history, across millions of years, preserved not in structures, but in chemistry, in patterns of erosion, and in the minerals themselves. The Earth is a patient archivist. Volcanoes, rivers, glaciers, and tectonic movements constantly reshape its surface, erasing many signs of what is past, yet simultaneously compressing and preserving others. Coal seams store the carbon of forests long gone. Limestone encases the shells of creatures that swam before humans existed. Metallic deposits occasionally reveal concentrations that defy natural explanation. Time buries evidence, but in the act of burial, it often secures it against total annihilation. Artifacts of unimaginable antiquity could already be folded into the crust, waiting for the moment we learn to read them. Geologists have long recognized the cyclical nature of planetary change. Supercontinents form and break apart. Oceans open and close. Glaciers advance and retreat. Within these cycles, life itself is both fragile and resilient. Mass extinctions wipe the slate clean, yet ecosystems rebound, sometimes repeating forms and behaviors that had existed before. Could intelligence, too, follow such a pattern? Could there have been species capable of shaping tools, harnessing fire, and building structures, only to vanish and leave behind a ghostly footprint in sediment layers and chemical imbalances? Some evidence, though subtle, is already detectable. Anomalies in metal deposits, unusual isotopic ratios, or the presence of synthetic-like molecules in deep strata hint at interventions that cannot be fully explained by natural processes alone. While mainstream science demands extraordinary proof for extraordinary claims, the fact remains that Earth's record is far from complete. Vast swaths of the planet remain unexplored. The deep oceans, ancient riverbeds, and subterranean layers may hold more than we currently dare to imagine. There is also a temporal dimension to consider. Human memory is short, spanning centuries at most. Geological memory, however, spans millions of years. A civilization existing tens of millions of years ago would have left a record compressed and altered. yet not obliterated. Erosion would reduce structures to fragments, but chemical markers could remain. Fossilized residues of industrial activity, trace metals, or altered isotopic ratios might all be waiting for the discerning eye, clues to civilizations erased by time yet recorded in the Earth's own data. The possibility of lost civilizations challenges our assumptions about history and our place in it. We tend to think of ourselves as pioneers, the first to invent, the first to master fire, the wheel, and metallurgy. But if other intelligences existed before us, we may simply be participants in a repeating cycle, rediscovering ideas that had already been realized long before. Our sense of progress, linear and forward-moving, may be an illusion. The past could be more layered and recursive than we imagine. Even myths hint at this recursion. Tales of golden ages, cataclysmic floods, and divine destruction appear in cultures across the globe. Perhaps these stories encode memories of catastrophes that ended previous civilizations, of technologies so advanced that they were feared or misunderstood, or of societies that rose and fell in cycles we cannot yet perceive. Myths may serve as the cultural fossils of memory, preserving the essence of knowledge long after the tangible evidence has faded. To search for the lost civilizations of deep time is to accept uncertainty and to embrace imagination tempered with reason. It requires us to look for anomalies, patterns, and whispers in places often overlooked, not only in ruins, but in rocks, sediments, and the chemical composition of the planet itself. It is an invitation to consider that intelligence is not confined to the present, but may be a recurring phenomenon, arising wherever conditions allow, leaving behind traces that patiently await rediscovery. Ultimately, the Earth itself becomes a living archive, a layered testament to life, change, and perhaps intelligence beyond our comprehension. Every mountain, valley, and sediment layer is a record of what has occurred, some pages legible, others nearly invisible. By studying these layers with care, curiosity, and humility, we begin to read the story of the planet in a new way, not as a linear history of humanity alone, but as a narrative that stretches far deeper, into eons that may conceal the legacy of minds that came before us. The sky has always been a canvas for human curiosity. From the earliest nights, when our ancestors lifted their eyes to the stars, we have sought to measure, predict, and understand the heavens. Constellations were mapped, calendars devised, and the movements of planets recorded with astonishing accuracy. These endeavors seem natural, even inevitable. Yet when we consider the possibility of civilizations long lost, the heavens may also be a repository of knowledge, a mirror reflecting not only the laws of nature, but perhaps the intelligence that once walked the earth before us. Astronomy, after all, is both practical and philosophical. Ancient peoples tracked celestial cycles to guide planting and harvest, to predict floods, or to navigate oceans. Yet, in the precise alignments of temples, pyramids, and stone circles, we see an interest that goes beyond the pragmatic. The structures of ancient civilizations often correspond to solstices, equinoxes, or the rising and setting of particular stars. This is true across continents and eras, from Stonehenge in England to the pyramids of Egypt, from the observatories of Mesoamerica to the megalithic sites of Malta. Such precision implies an understanding of time and space that is remarkable, especially when considered in light of the limited technology of these societies. What if these alignments are not merely inventions, but rediscoveries of knowledge that existed before recorded history? Could earlier civilizations, perhaps those lost in deep time, have observed the same celestial patterns, noting the movement of stars, planets, and moons in ways that informed their own understanding of mathematics, physics, and technology? The sky is unchanging in its cycles, repeating over millennia, and it is conceivable that any intelligent species would eventually notice the same rhythms. In that sense, our own astronomy might not be an origin, but a reawakening, a continuation of knowledge once known and then obscured by the passage of time. Consider the phenomenon of precession, the slow wobble of the Earth's axis, which alters the apparent position of stars over thousands of years. Ancient texts sometimes reference knowledge of precessional shifts, suggesting that certain cultures observe the heavens over timescales far longer than a single human lifetime. Could it be that these observations, embedded in mythology and ritual, are echoes of earlier intelligences? Perhaps the patterns we see reflected in myths, in gods and constellations, are memories of a civilization that measured the stars and encoded its understanding in story, ensuring that fragments of their knowledge would survive even if the society itself vanished. Even today, the night sky acts as a measure of time and an archive of the universe's history. Light from distant stars travels for millions, even billions, of years before reaching us. We see the past when we gaze at the cosmos, witnessing events long extinguished yet recorded in the photons that cross space. In this way, the universe preserves memory, just as Earth preserves traces of lost civilizations. Perhaps intelligence, like starlight, leaves a record not only in physical artifacts, but in the very patterns of the cosmos, waiting to be interpreted by minds capable of reading it. Beyond mere observation, ancient people also sought to manipulate the heavens. Megalithic structures, alignments, and shadow-casting mechanisms suggest the beginnings of applied astronomy, where observation meets technology. Could earlier civilizations, now vanished, have accomplished the same, building tools to measure, predict, and even harness celestial forces? While speculative, the recurrence of complex astronomical knowledge across distant and unconnected cultures invites us to consider that the sky may be a constant teacher, a repository of patterns that any intelligent being might eventually decode. Mythology, too, often preserves astronomical insight. Stories of gods moving across the sky, great floods timed with cosmic events, and celestial battles may be more than allegory. They may encode precise observations, the kind of knowledge that a previous civilization could have embedded in narrative to preserve it for future generations. By encoding understanding in story, such civilizations might have safeguarded intelligence against the destructive forces of time, ensuring that fragments could survive in symbolic form even if physical artifacts vanished. The study of ancient astronomy thus becomes a meditation on continuity. Every observation we make, every star chart we draw, every model we construct is part of a lineage that may stretch far deeper into history than we realize. The earth preserves, the sky preserves, and in both we may find faint echoes of predecessors, intelligent beings who sought to understand the cosmos, just as we do now. Their methods, lost to the sands of time, may yet live on in our own pursuit of knowledge, a silent dialogue across millennia. In contemplating the skies, we confront the possibility that human ingenuity is part of a recurring pattern, a rhythm that cycles through time. Technology, observation, and understanding may be less about discovery than rediscovery, the universe offering its lessons repeatedly to any mind willing to pay attention. The heavens, eternal and patient, remind us that intelligence is not necessarily unique to our era, and that the search for knowledge may be a story written in layers, both on Earth and across the stars. Thus, every glance upward carries the weight of history, memory, and possibility. Each constellation, each planetary orbit, each distant flicker of starlight may be a page in a book of wisdom far older than humanity, waiting for those who can read it. In the alignment of stone and star, in the myths of gods and heroes, in the precise calculation of celestial cycles, the echoes of deep time speak. And if we listen, we may realize that the sky itself is a witness, preserving the memory of those who came before, whispering the continuity of intelligence across the ages. Beneath the surface of what we call history lies a persistent question. What happens to knowledge when it is lost? Human memory is fragile. Civilizations rise and fall, and entire bodies of technology, science, and art can vanish almost overnight. Fires, floods, wars, and neglect erase the tangible evidence of innovation, leaving behind only fragments, stories, or myths. Yet the essence of knowledge, the principles, the understanding of cause and effect, the logic of mechanics and energy, may persist in subtle ways, hidden in culture, encoded in symbols, or awaiting rediscovery. To study lost technology is to confront the interplay between impermanence and persistence, between erasure and remembrance. Every civilization produces a body of tools, techniques, and understanding. These are not mere conveniences. They are reflections of thought itself, materialized in metal, stone, or organic materials. Once a tool is lost, its function may be forgotten, but sometimes traces remain. A peculiar alloy, an irregular fossilized residue, or even the imprint of a machine in sediment can endure long after the minds that created it are gone. Archaeology often focuses on what can be seen, yet the true fossil of intelligence is sometimes chemical, isotopic, or energetic, the residual effect of minds shaping matter in ways nature alone would not. Consider the rise and fall of classical civilizations. In Alexandria, the library once held centuries of accumulated knowledge, mathematical treatises, astronomical tables, mechanical diagrams. When the library was destroyed, much of this knowledge was thought to vanish. Yet echoes of it persist, embedded in fragments, translated copies, and later works that preserved principles rather than exact details. This is a pattern repeated across history. Knowledge, once developed, rarely disappears entirely. It morphs, hides, and resurfaces in new forms. Its physical manifestations may be destroyed, but its conceptual traces endure in culture, story, and occasionally in the very materials of the earth. What if such persistence extends far beyond recorded history? Could the earth itself hold records of technological achievement from eras we cannot yet imagine? Chemical anomalies in sediment layers, unusual isotopic ratios, or structures that defy natural explanation might be the fossilized signatures of civilizations long before our own. If intelligence arises repeatedly, and if its byproducts leave detectable traces, then the planet may contain archives far older than the earliest written records. The Earth may remember what we do not. Technology is, in essence, the externalization of thought. When we manipulate fire, metals, or energy, we are imprinting our understanding onto matter. These imprints endure longer than memory alone, becoming a form of preservation. A hammer, a wheel, a metallurgical process. Each is a thought made concrete. Even if the physical artifact decays, the process it embodies may remain latent, waiting to be reinvented. When we see patterns in ancient ruins or find anomalies in the geological record, we may be glimpsing the residue of knowledge that has survived, hidden in plain sight, yet transformed by time. Myths, legends, and oral traditions also serve as repositories for lost technology. Prometheus stealing fire, Vimanas in ancient texts, and automata in Greek myth may encode practical knowledge in symbolic form. These stories are not arbitrary. They are memory distilled through generations, adapted to survive in forms that are resilient to societal collapse. In this way, narrative becomes a secondary medium of preservation, a complement to physical evidence, ensuring that essential principles are never entirely lost, even when the details fade. The fragility of knowledge highlights the paradox of technological progress. The more advanced a civilization becomes, the more vulnerable it may be to losing what it has created. Complex machines require infrastructure, maintenance, and understanding. Once these are gone, the knowledge can vanish faster than simpler tools. Yet, paradoxically, every act of invention leaves traces. Even after disappearance, residual materials, chemical signatures, and mythic memory persist, waiting for minds capable of decoding them. Time, in this sense, is both destroyer and archivist. It erases, compresses, and transforms. It buries cities beneath sand, oceans, and rock, but it also preserves them in ways subtle and enduring. A lost civilization is not necessarily gone. Its presence may linger in layers of stone, sediment, and story, detectable only to those willing to interpret the faint signals left behind. By studying these residuals, we can glimpse patterns of intelligence that stretch far beyond the span of recorded human history, suggesting that what we call invention may be rediscovery, rather than original creation. Thus, lost technology is never truly lost. It exists as memory imprinted on matter, as principles embedded in stories, and as echoes detectable to careful observation. Every artifact, every anomaly, every myth may be a clue to knowledge that predates our civilization. In exploring these traces, we engage in a dialogue across time, piecing together fragments to understand not only what was known, but the enduring human, or perhaps universal, drive to understand, to create, and to leave an imprint on the world. The persistence of knowledge reminds us that intelligence is more than invention. It is pattern recognition, adaptation, and transmission across generations. Even when civilizations vanish, the essence of their understanding may remain, compressed into subtle signatures in the planet itself, awaiting discovery. The study of lost technology is therefore a meditation on continuity, resilience, and the quiet endurance of thought, a reminder that even erasure leaves a faint but discernible trace for those who know how to read it. Energy has always been the heartbeat of civilization. Without it, nothing moves, nothing changes, nothing grows. Fire, the earliest form of harnessed energy, allowed humans to cook, to forge, to illuminate darkness, and to transform raw materials into tools. But energy is not just physical. It is symbolic, philosophical, and profoundly transformative. It powers not only technology, but thought itself, driving intelligence to explore, experiment, and imagine. Understanding how energy is captured, stored, and applied is central to all civilizations, and the mastery of energy often marks the difference between survival and disappearance. From the earliest water wheels to modern electricity grids, every civilization's reach is limited by how it accesses energy. Watermills harnessed the flow of rivers, windmills captured the invisible currents of air, and fires of coal and wood heated homes and smelted metals. Energy shaped the environment and, in turn, defined what societies could build, how far they could travel, and what technologies they could develop. But what if earlier civilizations, now lost to time, had mastered energy in ways that we can scarcely imagine? Could the echoes of such mastery persist, hidden in the chemical record, in isotopes, or even in geological anomalies? The concept of energy extends beyond combustion or mechanical work. Electromagnetic forces, gravitational manipulation, and chemical potential all hold the keys to transformation. A society that understands these forces deeply can manipulate its environment in ways that seem almost magical to later observers. Stories of flying machines, self-moving automata, and energy-based tools, found across cultures and millennia, may reflect the persistent human fascination with harnessing energy, or perhaps even faint echoes of actual technologies long erased. These myths are not merely fanciful tales. They may encode principles, ethics, and warnings about energy use, preserved symbolically across generations. Consider the Industrial Revolution, a brief but intense awakening of energy mastery in human history. Coal and steam engines transformed society, altering landscapes, ecosystems, and atmospheres. The byproducts of this energy, chemical residues, altered isotopes, and vast environmental shifts, will persist for millions of years. This demonstrates that energy use leaves detectable traces far beyond the span of a civilization. If earlier, now vanished societies had similarly harnessed energy, their signature may still exist, buried in sediments, trapped in rocks, or encoded in the isotopic composition of the Earth itself. Energy is also intimately tied to the ethical dimension of intelligence. The stories of Prometheus, of divine punishments for fire, or the cautionary myths of power misused, reflect a deep awareness of energy's dual nature. It can build, sustain, and illuminate, but it can also destroy, consume, and annihilate. Mastery of energy requires not just understanding, but wisdom. Many lost technologies may have disappeared not due to inability, but because the civilizations that wielded them faced the consequences of misapplied energy, environmental collapse, resource depletion, or self-inflicted catastrophe. In this sense, energy is both a tool and a test. The study of energy in ancient or lost contexts challenges our assumptions about linear technological progress. Humans often see energy mastery as sequential: fire, wheels, steam, electricity, nuclear. Yet, if previous intelligences existed, their approach may have been different, exploiting forces we have yet to rediscover, using principles that modern science only now begins to explore. Piecing together these possibilities requires reading indirect signs, unusual mineral deposits, remnants of engineered thermal gradients, or chemical anomalies suggesting industrial-scale manipulation. The traces may be subtle, almost imperceptible, but they could be as real as the tools themselves. Even in contemporary times, energy shapes civilizations' resilience and longevity. Societies that can store, transmit, and apply energy efficiently can thrive, while those that mismanage it decline. This principle is universal. Intelligence, when combined with energy, becomes transformation, the ability to alter landscapes, climates, and even biological systems. It is plausible, then, that any intelligent species capable of technology would encounter this same threshold. The fossil record of energy use in all its forms may be the most enduring testament to intelligence itself. Energy is memory as well as force. Fossil fuels, isotopic ratios, and mineral anomalies are archives of previous combustion, chemical reactions, and industrial activity. They preserve the imprint of work done, effort expended, and transformations achieved. To read these imprints is to glimpse not only the actions of the past, but the thought processes that guided them. In essence, energy leaves a signature of cognition, a fossil of intention made material, waiting for an observer capable of interpretation. The mastery of energy is inseparable from the mastery of survival. Fire, water, wind, and more abstract forces like electricity are the tools by which intelligence extends its reach beyond biology. Civilizations that fail to harness energy wisely vanish. Those that succeed shape history and perhaps leave whispers in the geological and mythological record. Energy, therefore, is both measure and mirror. It measures the capacity of intelligence and reflects the ethical choices that accompany power. Ultimately, energy connects past, present, and future. The flow of rivers, the combustion of forests, the radiation of stars, all are forms of energy that civilizations tap, interpret, and transform. By examining the residues, myths, and patterns associated with energy use, we can trace a lineage of intelligence that transcends time. Energy is both ephemeral and enduring. It consumes, it creates, it leaves traces that outlast the architects themselves. In understanding energy, we come closer to understanding the pulse of civilization, the persistence of intelligence, and the delicate balance between creation and destruction that defines every technological journey. Materials are the silent storytellers of civilizations. They carry knowledge in their composition, in the ways they are shaped, combined, and transformed. Clay becomes brick, metal becomes tool, glass becomes lens. Each transformation is a decision, a demonstration of understanding of the physical world, a translation of thought into matter. Even when a civilization vanishes, its materials persist. Stone endures, metals oxidize slowly, plastics fragment but do not entirely disappear, and ceramics can survive for millennia. In this way, the earth itself becomes a library, and every artifact a page in a book written in chemical bonds and mineral structures. Consider the processes by which materials are manipulated. Smelting ores, refining metals, and creating alloys require knowledge of heat, chemical reactions, and mechanical techniques. The durability of steel, bronze, or ceramics is not accidental. It reflects centuries of experimentation, trial, and refinement. A single surviving shard or ingot can reveal the principles of metallurgy, the sophistication of tools, and the priorities of those who created it. Now imagine similar processes carried out by civilizations that predated humanity. Even if their cities and machines have vanished, the materials they worked with could leave subtle traces. Unusual isotopic ratios, highly refined metals, or synthetic compounds preserved in rock layers. These would be the technofossils of an intelligence now lost to time. The study of ancient materials teaches us that knowledge is often embedded in matter long before it is recorded in words. A perfectly aligned brick, a carefully tempered alloy, or a composite material that resists corrosion demonstrates mastery over forces that can endure beyond memory. Materials are both practical and symbolic. They preserve intent, the choice of a metal, the method of firing, the structure of an object. all encode decision-making, problem-solving, and creativity. They are the residue of intelligence, waiting to be interpreted by attentive observers. Even in natural materials, we find records of manipulation that defy expectation. Certain sedimentary layers contain concentrations of metals, carbon, or silicon that do not fit with natural deposition alone. These anomalies may be the result of geological processes, yet they could also be the byproducts of technological activity, long buried and subtly preserved. By studying these anomalies, scientists can glimpse activities that predate recorded human history. Perhaps even the construction of massive machines, large-scale energy manipulation, or industrial processes of ancient civilizations left signatures in minerals, ores, or sediments that have survived erosion, subduction, and tectonic change. Materials also preserve experimentation, failure, and adaptation. Ceramics may crack under thermal stress, metals may oxidize, and glass may fracture. Each imperfection tells a story of trial, correction, and understanding. In this way, the very flaws of artifacts can be as informative as their successes. They record the process of intelligence engaging with the natural world, the learning, adaptation, and problem-solving that define technological progress. To uncover patterns in materials is to trace the thought processes of those who lived long before us, encoded not in words, but in the choices they made when shaping matter. Some materials are almost miraculous in their endurance. Obsidian blades, certain alloys, and vitrified ceramics can survive for hundreds of thousands of years under the right conditions. Plastics, though prone to fragmentation, persist as microplastics that will endure for millions of years. In this sense, materials become a bridge across time, preserving knowledge and action when architecture, writing, or machinery cannot. They form a subtle, persistent record, detectable by chemistry, spectroscopy, and microscopy, offering a window into past ingenuity that the eye alone cannot perceive. The concept of material memory extends beyond physical durability. Materials respond to energy, stress, and environment. Metals retain microstructural changes from forging. Ceramics carry thermal histories. Rocks record pressure and heat from human or natural intervention. By examining these histories, scientists can infer processes, techniques, and even intentions. Each material becomes a narrative of action, an archive of intelligence embedded in matter. The Earth itself, composed of countless layers of minerals and sediments, thus becomes a living record of interaction, a palimpsest of natural and artificial forces intertwined. The durability of materials also emphasizes the ethical dimension of intelligence. A society's choice of materials and the care or disregard in their manipulation determines what survives and what disappears. Durable choices preserve knowledge, extend influence, and transmit understanding across generations, while ephemeral or poorly managed choices are lost. In this way, material selection is both practical and philosophical. It reflects foresight, values, and understanding of permanence. Materials encode wisdom, caution, and the priorities of civilizations, both human and potentially pre-human, for eons to come. Even the simplest materials bear witness. Clay shaped into bricks, stones carved for alignment, or wood treated for preservation reflect the interplay between human intention and natural forces. The combination of selection, modification, and endurance transforms ordinary matter into a repository of thought. Over millions of years, even as cities crumble, monuments decay, and artifacts are buried beneath layers of sediment, the materials themselves endure, quietly transmitting evidence of intelligence to those who know how to read them. Ultimately, the study of materials is the study of civilization itself. They are the tangible, enduring traces of thought made manifest, the residue of intention, and the silent testimony of knowledge. Through materials, we can detect patterns, methods, and even philosophies of societies long vanished. In rocks, metals, ceramics, and synthetic compounds, intelligence leaves a faint but discernible signature, a record that survives the erosion of time and the forgetfulness of memory. Materials, in essence, are the Earth's memory, patiently waiting for discovery, interpretation, and understanding. The mind is the most intricate machinery of all, a network of neurons capable of imagination, abstraction, and invention. Yet intelligence is never fully confined to the brain alone. It manifests through the tools we create, the patterns we recognize, and the structures we build. Every civilization that has developed technology has extended its mind into the material world, embedding thought into tools, buildings, and machines. When we consider civilizations long lost, the same principle may apply. Intelligence may have externalized itself through objects, structures, or even environmental modifications, leaving traces of reasoning and purpose that endure far longer than the fragile lives of the beings who created them. Memory itself may be more than neurological. It is a pattern recognition system, a capacity to understand cause and effect, and a drive to manipulate the environment to achieve desired outcomes. Civilizations externalize these processes in ways that survive time. Roads, canals, energy conduits, and machines all encode decisions, priorities, and methods. The precise placement of stones, the refinement of metals, or the orientation of a structure in alignment with celestial bodies reflects more than utility. It reflects the cognitive and philosophical capacities of its creators. These are traces of thought fossilized in matter, enduring far beyond individual lifespans. The concept of lost intelligence challenges our perception of linear history. We assume that progress is sequential, that humans are the first and most advanced intelligence on Earth. Yet if intelligence is recurring or cyclical, then traces of thought may exist in layers of sediment, hidden in isotopic ratios, or encoded in materials we have not yet learned to interpret. Just as the brain leaves chemical signatures and patterns, civilizations may leave macro-scale cognitive imprints, engineered landscapes, modified waterways, or arrangements of matter that serve no natural purpose but demonstrate design. These are the echoes of minds that once understood and altered their world in ways we may only now begin to comprehend. Artificial intelligence, robotics, and automation in the modern age reveal the timeless aspiration to externalize cognition. By creating machines that act upon instructions or adapt to conditions, humans extend the reach of their minds beyond their bodies. Ancient civilizations may have pursued the same impulse, though in forms now lost. Automata, mechanical devices, and even structural alignments may all be evidence of intelligence attempting to preserve itself in the material realm, to continue functioning even if the creators themselves were gone. The act of building, shaping, and encoding is a form of immortality, a way for thought to survive decay and oblivion. Even natural environments can carry cognitive signatures. Terraced fields, manipulated riverbeds, and cultivated landscapes reflect decisions, planning, and foresight. These modifications endure, sometimes for millennia, creating a record of intelligence interacting with ecology. If civilizations predate recorded history, perhaps similar large-scale modifications exist, buried under layers of sediment, obscured by erosion, or submerged beneath oceans. Traces of intelligence may be subtle, detectable only by careful study of patterns, anomalies, and repetitions that defy purely natural explanation. Language itself is a form of externalized intelligence, but so too are symbols, diagrams, and structured objects. A complex machine, aligned stones, or engineered conduit all encode rules, logic, and methodology. To decode these is to engage in a dialogue across time, interpreting the decisions and priorities of minds long vanished. The potential longevity of these cognitive signatures is astonishing. While biological intelligence fades, the effects of its application on the material world can persist for eons, awaiting discovery by observers capable of perceiving design and intent. The notion of lost intelligence also invites us to reconsider our place in history. Humans may not be the first, nor the last, to develop technology or complex thought. If intelligence is an emergent property of sufficient environmental and evolutionary conditions, then the traces of earlier cognitive beings may be scattered across geological, oceanic, and atmospheric archives. The challenge lies in recognizing patterns where nature and design overlap, discerning intentionality from randomness, and interpreting faint signals preserved across immense spans of time. Even memory embedded in matter is vulnerable to distortion. Geological processes, climate shifts, and environmental change can obscure, compress, or transform cognitive imprints. Yet paradoxically, these same forces preserve aspects of intelligence, sometimes in forms that survive longer than any written record or machine. Fossilized residues, isotopic anomalies, or remnants of engineered structures can act as enduring signatures of thought, preserved in a natural archive that transcends human perception. Thus, intelligence is both ephemeral and eternal. Minds may vanish, yet the patterns of reasoning, the extensions of cognition into matter, and the traces of applied knowledge endure. By studying anomalies, materials, alignments, and environmental modifications, we may begin to discern these echoes, glimpsing the presence of minds that once shaped the world. In this way, the Earth itself becomes a repository of thought, a layered archive of intelligence written not in ink, but in stone, metal, and sediment, whispering stories of ingenuity that stretch across epochs. Ultimately, the study of lost intelligence is a meditation on persistence, memory, and creativity. It reveals that thought can outlast life, that cognition can manifest materially, and that intelligence, once it touches the world, leaves a signature detectable across unimaginable spans of time. Every anomaly, every alignment, every artifact may be a message from minds long vanished, a testament to the enduring capacity of intelligence to shape, preserve, and speak across the ages. The passage of time is a sculptor, slowly reshaping landscapes, eroding mountains, and wearing down the monuments of civilization. Yet it is also a preserver, compressing sediment, freezing organic matter, and trapping the chemical signatures of activity in rock and soil. In this dual role, time records and erases simultaneously, creating a palimpsest of history in which civilizations, both known and potentially unknown, leave traces that endure long after they vanish. To explore the work of time is to consider both its destructive power and its extraordinary capacity to archive, to encode memory into the very substance of the earth. Every act of civilization, the forging of metal, the carving of stone, the construction of buildings, interacts with geological processes. Over centuries, rivers shift courses, soils erode, and tectonic forces upheave landscapes. Yet, these same processes bury artifacts in ways that can preserve them for millennia. A city swallowed by sand may vanish from view, but the layers beneath hold chemical and structural imprints of human activity. Volcanic ash, sedimentation, and mineral deposits act as a kind of slow-motion archival system, recording the presence and actions of intelligence even when the surface bears no sign. Time does not discriminate between civilizations. Whether a society wields bronze tools, steam engines, or advanced electronics, its imprint on the planet is subject to the same laws of decay, compression, and transformation. Fossilization, mineralization, and sedimentation all preserve aspects of the past in ways that modern archaeology and geochemistry are only beginning to decipher. Patterns emerge in isotopic anomalies, concentrations of metals, and unusual chemical residues that may hint at the presence of intelligent activity long before written records began. Time, in this sense, becomes both witness and archivist, silently cataloging what the eyes of humans may never see. Consider natural catastrophes. Floods, earthquakes, and volcanic eruptions can obliterate structures almost instantaneously. Yet paradoxically, they also preserve evidence. Buried beneath ash or silt, artifacts and traces of civilization may survive in a kind of suspended stasis, protected from the erosive forces that would otherwise erase them. Pompeii, buried under volcanic ash for nearly 2 millennia, offers a vivid illustration of this principle. The same might apply on a far grander scale for civilizations lost to prehistory or deep time, with entire landscapes preserved under sediments, glaciers, or oceanic deposits, waiting to be uncovered by patient investigation. Time also operates on scales that exceed human comprehension. Geological epochs stretch across millions of years, dwarfing the lifespan of individual civilizations. Tectonic plates shift, mountains rise and fall, and oceans advance and retreat. Within this immense temporal framework, Even the most ephemeral human constructions are absorbed into the geological record. Yet their presence is not entirely erased. It is transformed. Buildings become rubble, metal corrodes, and organic materials decompose, but subtle signals remain. Altered mineral compositions, anomalous isotopes, and chemical signatures that betray prior activity. Time preserves knowledge in ways that are subtle, encoded in matter itself rather than in memory alone. The interplay of decay and preservation extends beyond the physical. Cultural memory, transmitted through myths, legends, and stories, interacts with the temporal landscape. Tales of floods, catastrophes, and divine interventions may encode knowledge of events, technologies, or civilizations long vanished. These narratives act as a secondary layer of preservation, ensuring that while material artifacts may vanish, the conceptual traces of intelligence can endure across generations. Myths thus complement the geological record, forming an interwoven archive of human and planetary memory. Even in the present day, we witness the dual nature of time. Urban ruins crumble, industrial byproducts corrode, and natural landscapes slowly reclaim human interventions. Yet every trace leaves a footprint, chemical or structural, detectable to those with the knowledge and tools to interpret it. Satellites map ancient riverbeds, sonar reveals submerged landscapes, and isotopic analysis uncovers anomalies in rocks and sediments. These methods allow us to see the record that time has preserved, often in places where we least expect it. Ultimately, time is impartial. It erases indiscriminately, but it also archives meticulously. It challenges the permanence of civilizations while simultaneously ensuring that the signatures of intelligence, ingenuity, and creativity are encoded into the very fabric of the earth. The planet becomes a layered manuscript, with chapters hidden beneath rocks, sand, and water, each waiting to be read by minds capable of interpreting its silent language. By observing how time transforms and preserves, we come to appreciate the resilience of memory, both natural and artificial. We begin to understand that even when civilizations disappear, their traces can endure subtly, chemically, structurally, across eons. Time acts as a bridge between past and present, revealing the persistence of intelligence and the continuity of action long after the actors themselves have vanished. In this light, the Earth is not merely a passive stage for human activity. It is an active participant in the preservation of memory. Mountains, rivers, glaciers, and oceans all archive events, shaping the survival of traces in ways both violent and gentle. To study time is to study the resilience of knowledge itself, to learn how civilizations, whether human or otherwise, can be lost and yet remain, faintly, in the silent, enduring record of the planet. Human curiosity has always been drawn to the edge of what is known and the boundary of what is forgotten. We look to the stars, we dig into the soil, we study materials, and we contemplate the past, seeking to understand the lineage of knowledge and intelligence. Yet there is a particular fascination with what has been lost, technologies, civilizations, and ideas erased not by negligence, but by the relentless passage of time. These lost elements invite speculation, imagination, and reflection. They remind us that history is not only what is recorded, but also what endures in hidden forms, waiting to be discovered by minds attuned to subtle traces. The possibility of lost technologies challenges our assumptions about human uniqueness. We often perceive ourselves as the first and most advanced civilization, charting a linear path of progress. Yet the Earth is an ancient archive, holding sediment layers, isotopic anomalies, and mineral compositions that could hint at intelligence long before humanity rose. Could there have been civilizations that harnessed energy, manipulated materials, and observed the heavens with precision we today struggle to imagine? These questions stretch our understanding of time, intelligence, and the persistence of knowledge. They suggest that invention may not be purely original, but sometimes a rediscovery of principles already understood, long before written records. The echoes of lost technology are embedded in many forms. Artifacts no longer visible may leave chemical signatures in soil, Isotopic anomalies may mark industrial activity. Structures may be buried under sediment or submerged beneath oceans. Even myths and legends carry fragments of understanding, encoded symbolically to survive the collapse of civilizations. Stories of flying chariots, self-moving automata, or golden ages destroyed by catastrophe may preserve, in allegory, knowledge of engineering, energy manipulation, or astronomical observation. These narratives act as cultural fossils, safeguarding the essence of technology against the erosion of time. Time itself plays a dual role, as both destroyer and preserver. Rivers shift, mountains rise and fall, glaciers advance, and tectonic plates move, erasing and compressing traces of past civilizations. Yet in these same processes, preservation occurs. Volcanic ash entombs cities, sediment layers record chemical residues, and mineral deposits encode interactions between life and matter. The Earth archives activity on scales far beyond human perception. Even when cities vanish and machines decay, the principles behind their construction may remain, detectable in isotopic, structural, or chemical records. Energy, materials, and intelligence converge in these lost technologies. Mastery of energy enables transformation, whether through fire, mechanical force, or electromagnetic phenomena. Materials, carefully selected and processed, preserve evidence of human intention and ingenuity. Intelligence extends beyond the mind into the world, leaving imprints in tools, structures, and environmental modifications. When combined, these elements leave a signature that endures far beyond the lifespan of individual civilizations. Even if the machines themselves are gone, the principles encoded in matter, energy, and structure may survive. Exploring lost technology is not merely an archaeological pursuit. It is a meditation on the persistence of thought and intelligence. It encourages us to read subtle patterns, to interpret anomalies, and to recognize that knowledge can exist in hidden, indirect forms. The process of rediscovery requires humility and imagination, accepting that the past may hold surprises that challenge conventional narratives. Perhaps our own inventions are echoes of cycles long established, a continuation of discoveries made by minds we cannot name or fully understand. The study of lost technology also brings ethical reflection. Many myths warn of the dangers of power misused, of knowledge applied without wisdom. Civilizations capable of manipulating energy, materials, and information may have perished through environmental collapse, social upheaval, or unintended consequences. Technology is thus inseparable from responsibility. The endurance of traces reminds us that the choices civilizations make can outlast them, leaving signals, chemical, structural, or cultural, that inform those who follow. The interplay between memory, myth, and matter underscores the continuity of intelligence. Civilization may vanish, yet the imprint of thought persists in multiple forms. Stories, even distorted by time, preserve ideas. Materials preserve techniques. The Earth itself preserves traces of interaction between life and environment. By studying these layers, geological, chemical, and narrative, we gain insight not only into what has been lost, but into the enduring patterns of ingenuity, problem-solving, and curiosity. Even our modern technologies are subject to the same processes. Digital data decays, physical structures deteriorate, and chemical residues shift over time. The lessons of lost civilizations remind us that permanence is relative, that knowledge is fragile, and that preservation requires intention. Yet they also inspire hope. Traces of activity, even subtle, can survive if properly interpreted. The Earth, patient and impartial, archives all action, and with careful observation, these archives may reveal patterns of intelligence previously unimagined. Ultimately, the pursuit of understanding lost technology is a journey through time and consciousness. It calls us to recognize the persistence of intelligence, the resilience of knowledge, and the subtle ways in which civilizations communicate with the future. By listening to the faint whispers embedded in materials, sediments, myths, and celestial alignments, we begin to perceive a continuity that transcends individual lifetimes. Civilization is not solely a record of what survives visibly, but a network of patterns, principles, and traces that endure, awaiting recognition. To imagine lost technologies is to embrace wonder, curiosity, and humility. It is to accept that our place in history may be part of a larger, repeating cycle of intelligence and invention. The Earth, in its patience, holds the memory of all action, recording both triumphs and errors in a silent, enduring archive. In studying these traces, we honor the continuity of thought, the persistence of creativity, and the capacity of intelligence to shape the world, and to leave echoes that speak across millennia. In the quiet of reflection, we sense the presence of those who came before, not as ghosts, but as enduring signals encoded in matter, energy, and story. The machines that time tried to erase may have vanished from sight, yet their principles survive, hidden in the very fabric of the earth. To observe, to question, and to imagine is to participate in a dialogue across time, to touch the edges of memory and ingenuity that span epochs. And in that dialogue we find not only history, but a meditation on the persistence of intelligence itself, a testament to the enduring reach of thought, creativity, and the human desire to understand, to shape, and to leave a mark on the world.